This is Algebra lesson 12.4, multi-stage experiments. So in this lesson we're going to talk about independent versus dependent probabilities. Independent probabilities would be what you would expect when you are flipping a coin. For example, because you flip a coin, you either have heads or tails. The next time you flip a coin, you still have either heads or tails. The probability doesn't change. The first time it's 50-50, the second time it's still 50-50. The events do not affect each other. Whereas dependent or conditional probability would be like maybe picking marbles, where let's say you have 5 marbles in a bag, 3 blues and 2 reds, and you pick a marble and it's a blue, and you don't put it back in the bag. Now there's only 4 marbles in the bag, 2 blues and 2 reds. Every single time you repeat, the next event is affected by the one that came before it. And we like to think about this as no replacement. You did not replace that marble when you went to go pick your next one, so it affected everything that comes afterwards. If you did replace it, that would be independent. If you started with 5 marbles, picked a marble, put it back in the bag, and there's still 5 marbles in the bag, then all of those probabilities would be independent. They don't change after each event that happened. So the multiplication rule says if I want to get the probability of 2 things happening, event A and event B, first I need the probability that event A is going to happen, and then I'm going to multiply that by the probability of event B given that A has happened. So this is read B given A. If these events are independent, the probability of B given A is equal to the probability of B. But if they're dependent, that is going to change every time. So let's do some examples. Diane wants to determine the probability of various outcomes when flipping a coin. If she flips a fair coin 2 times, what is the probability that she'll get exactly 1 head? So I'm going to draw a big tree right here to help me enumerate this situation. When you flip a coin, that is heads or tails as your 2 possible outcomes. And the probability of each of those outcomes is 0.5. So let's say you flipped a head and you're going to flip your coin again. You still have the same 2 outcomes. These are independent probabilities, so they don't change. It's still a 0.5 for each. Let's say you flipped a tail the first time. The second time around you still could flip a heads or a tails. You still have a 0.5 chance of each happening. So when I want to get the probability of getting a head and another head, my multiplication rule is telling me to multiply those together. So the probability that I got to get a head and then get another head would be 0.5 times 0.5, which is 0.25. 0.25 is the probability of 2 heads. And since these are kind of 0.5s all over the place, all of these are going to be 0.25s. But the probability that I'm going to heads and then a tails would be 0.25. A tails and then a heads, another 0.25. And 2 tails in a row would be 0.25. So to answer the question that was asked, what's the probability that she'll get exactly 1 head, I would have to add together all of the outcomes that had 1 head. So here's 2 heads, here's 1 head, 0 heads. So I'm going to add together the ones that had 1 head, 0.25, and 0.25. That's a 0.5. 50% chance of getting exactly 1 head when flipping a coin 2 times. So now let's say we're going to flip the coin 3 times. And I'm going to get a little large on this. And I have heads and tails, heads and tails, heads and tails, heads, tails, heads, tails, heads, tails, heads, tails. And a 0.5 times a 0.5 times a 0.5. And all of these are going to be 0.5, so every one of these outcomes is a 0.125. Following along the top branches, that's getting 3 heads in a row. And then we have heads, heads, tails. And then heads, tails, heads. And then heads, tails, tails. And then we're on the bottom half. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads, and tails, tails, tails. 1, 2, 3, 4, 5, 6. Those are my 8 possible outcomes. What is the probability of getting exactly 2 heads? We're going to add together each of the outcomes that have exactly 2 heads. So I have 3 0.125s. There is a 0.375 chance, or 37.5% chance, of getting exactly 2 heads when flipping a coin 3 times. Okay, I'm going to erase this big guy so I have more space to do letter B. But it says, Cheryl makes 75% of her first tries at the free throw line. However, her records indicate that her success on the second throw depends on her success on the first throw. If she gets a good, if she makes the shot, she makes 80% of her second shots. If she misses the first shot, she only makes 50% of her second shots. What is the probability that Cheryl will get 2 consecutive good shots? So, she's either a good or a miss, and she is good 75% of the time on her first shot. But she misses 25% of the time on her first shot. That isn't expressly said, but I know that if 75% are good, I need to make 100% total, so 25% and 75% make that 100%, 25% are missed. Okay, so if she's good the first time, she still has good or miss the second time, but this is a dependent situation, where when she does good the first time, she does even better the second time. So if she makes 80%, she's going to miss 20%. 80 and 20 make that 100% whole. If she misses the first shot, she still can good or miss the second time, but she does worse this time. She has a little confidence issue. She only gets 50%, which means she's going to miss 50% to make that 100% whole. So I'm going to use my multiplication rule. I do 75% times 80%, and the probability of getting 2 shots in a row now is 60%. The probability of getting a good shot and then a missed shot, so the first one in, the second one missed, would be 15%. The probability of missing the first shot and then getting the second shot would be 0.25 times 0.50, and that will be the same answer, 0.25 times 0.50. So to answer the question, what is the probability of getting 2 good shots? 2 good shots would be 60%. That is it for the notes. You will use this tree from example B to help you do number 1 in the exercises, so make sure you have that down. And good luck with the exercises, and please let me know if you have any questions.